Hello guys, welcome to CADNet. This is our 10th class. So in this class, we are going to see wireframe and surface design workbench. So in this, the surface modeling, the need of surface modeling. The product and industrial designers are giving special importance to product styling and providing a unique shape to components. Generally, this is done to make product look attractive and presentable. So So here the product shape is managed using the surface modeling techniques. So, so first of all, there is no thickness to the surface and they do not have the mass properties. So CATIA V5 provides you a number of surface modeling tools to create a complex three-dimensional surface models. So the various workbenches in CATIA V5 are wireframe and surface design is the first one. The second one is generative shape design, and third one is a freestyle. So, so in this class, we are going to learn about the surface modeling tools in the wireframe and surface design workbench. And coming to this generative shape design and freestyle, we will be seeing in our advanced classes. So, coming to this wireframe and surface design, let's go for let us start in mechanical design, and here you can find see wireframe and surface design. The same way, uh, the second tool is the generative shape design, which is not there here. The third one is a freestyle, even that is not seen in the mechanical design. So I think those you can find in the shapes. So here in the shape you can see the freestyle and the generative shape design. These are about this too. And so coming to the mechanical design, go for this wireframe and surface design. And okay, so now we are in the wireframe and surface design workbench. So here if you see, firstly go to the sketcher workbench. Here you can see the circle. Before going to sketcher, here in the wireframe itself you can find the different 2D options which are used in 3D space. So here the one of the option is here is the circle. This is used to create options like arc and circles. Select it. So here in the circle definition, there are different types of circles: center and radius, center and a point, 2 point and radius, 3 points, center and axis, bitangent and radius, bitangent and point, tritangent and point, center and the tangent. So you can little use the center point, create point, and by default it will be the origin. Click OK, and the radius I am giving as 100. So I need to mention the support here. I'm selecting this plane as the support, YZ plane. So if you see the start angle and the end angle, you can just drag here, or even you in the circle limitations, if you select this complete circle here, whole circle, then there is no problem of giving angles. There's no need of giving angles. Only you can vary here is the radius. You can just drag here, or you can just change here. So this is about the circle definition. How to create the circles here in the wireframe and surface design. So here also there are different types which are not so difficult to work on it. So you can please try them. These are not such difficulty here. You can just you support giving 2 points and radius, and you need to give two different points. If you don't have the points, just you can right click and you can create a point by using any of these options. And then the support, you can give the support as a plane on which you want to create, and then you can just simply create a complete circle or a trimmer circle or a complementary circle. So this is how you can even see the solutions, different possibilities of circles. So you can try these things in the circle definition. It is not much criticality here. There is no criticality, so you can try them. So well, we are going moving to the next one. That is nothing but creating splines. So in the circle drop down, you can see different types of circle, and here is a corner, and here is a connect curve. So these are creates a corner between two curves. There's nothing but something like a fillet. So in this workbench, it is represented as a corner instead of fillet here. So here connect curves. So if we create two different curves, for suppose create two different curves, and you can select this option and can select the two curves, two endpoints of the curves, then that will be connected by a new curve here like this. As shown in the picture, you can clearly visualize how it works from the picture itself in the drop down. So this is about different options here. Corner and is similar to the fillet, and this is a connect curve. So we need to select the two curves here, first curve and the second curve, and the point on the first curve and the point on the second curve, and then continuity tangency. Can try these three things, and connect type can select base curve, normal curve, and you can use this feature, and same as this corner option. So you can select the first element and the second element, which are nothing but a lines or a spline, mostly the straight lines, and then can give the support by selecting any of the planes, and 3D corner or corner on support. You will get you can give the radius here and see the number of possibilities by selecting the next solutions if required. So this is about the corner definition with nothing but a fillet. So now we are going to creating a spline. In the splines there are two types mainly, spline and helix. So firstly, if you go for the spline here, select the spline. So you can see here different like number, points, tangent direction, tangent, curve direction. Right click, create point, okay, and again right click, create point, give the value you like. So again right click, create point, and 100, okay. So like this you can right click and add points, and then can add points in between of 2 and 3 or 1 and 2, or you can replace the point, and for second point which is selected you can replace the point. And in the geometry on support you can select any plane, just remove this. You can select closed spline, then it's getting closed by itself. Okay, got a closed spline passing through the all the 3 points. Constraint type explicit from curve. So constraint type explicit from curve. So you can just see the differences from them. So here you just you see here the replace point and geometry and support. Coming to this geometry and support, as I told you, uh, select this and select any plane. You can see there's error message showing, so it is not possible to create the points, as I already created 3 points which are not lying on a plane, but they are in a 3D space, different distances from a center axis. So you want to create on a particular plane, you need to select this geometry and support and select a plane on which you need to create multiple points, or else you can just deselect this one so that the points will be created on a 3D space. So just click OK. So this is how it is created. So coming to the next one here is creating a helix. So if you see, just delete this one. See the spline definition. If you see the drop down here, you can see the helix option. Select the helix option. So this tool is used to create a helical curve. So you'll be prompted to select the helix starting point. So there is no any predefined point. Just right click and create a point at some distance. Okay, and axis. Select any axis. Uh, Suppose I am selecting Z axis, and now giving the pitch is shown here. You can see what is the pitch and what is what. Select the pitch. the distance between the two, distance between the two lines. And give the total height as here it is 100. Even you can double click and change here itself, or you can enter the value here, giving the value as 50. So 5 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 into 5 is the 50, so it get 10 rounds here. So the starting angle is 0 degrees. You can change the starting angle here. See the preview. The starting angle now with respect to the end angle here, and the taper. Can even give the taper. You can see the taper value changing here. You can increase the height 100 mm. You can see more clearly now the taper value. And you can give the inward or outward. Select outward. You can see the this angle is applied to outside. So taper angle applying to inward is, so if it's in the reverse direction, this is what happened. And coming to the your law, so start value 5 mm is a constant. This close. So even the pitch is changing, so it is linked to the pitch start value. So coming to this S type here, so start value is 5 mm and end value is 1 mm. So we just okay, let's go. And value is 50 figure close the preview. So the only got only one revolution. So if you just change the revolution, so this is the XS type. The law I can just start value is giving the 1 mm and the end value is giving 1000. So at the middle point it will reach up to 0.5 and it keeps on changing. And change the this S type. You can change the parameter, both the amplitude, the parameter can vary in the X into 1000, or you can give like 5 to start file, and then value as 10, and just close it. So these are some law definition, and you can just adjust the values here. Generally for constant law type it will be 5 mm. The start value is 5 mm. That is same as that of the pitch which you are given here. So coming to the next one, you remove the taper here, give the taper value 0, and in the profile you can create a profile here, create line, a point, first point, create point, okay, second point, create point, and give the value as 200, 100, 300, preview. You can just drag, click OK. So it is showing just cancel this one, and we'll do one thing. First we'll be creating a spline, create a point, this one give it the origin. Before that, geometry on support I am keeping as YZ plane. So now I am going to create a point on plane. So keeping the first point here, and again selecting the plane and keeping the second point here, again selecting the plane and keeping the third point here somewhere. So if you see, select that point and add point after 3, cancel. Add point before point 2, selecting point 2 and remove point, create point, or else select this point. Now we got a shape. Okay, now we created a spline. Now go for this helix here, and starting point I'm selecting is this, and axis I'm selecting as a right click Z axis, and pitch I'm giving as a 5, and height I'm giving as 200, change the pitching to 10, and height I'm giving as 1000. Let's give us 500 diagonal. Orientation clockwise or counterclockwise, start angle, and in the profile here selecting this line as a profile. So if you see here clearly, even whatever the height you have given, it won't affect the profile, because it will take the profile as a reference, and it will form the shape of the profile. So here you can see the taper angle and the way has been not highlighted, start angle also not highlighted, only the pitch is highlighted and the height is highlighted, and the orientation and the axis starting point. Let's see what will happen if we keep this not yet forming any. So this is about using the profile option, the radius variation block. So coming to the next thing, we are going to see the same spline can be created in Sketcher workbench also. Select delete, select this plane and go to Sketcher. The same spline can be created using this spline option. So here in the wireframe, it is possible to create in a 3D space the lines, points, and over the lines and points, the circles and the corners and connecting corners and the helixes. Those are can be created in the 3D wireframe and surface workbench itself instead of going to the uh, Sketcher workbench. Is one thing. And coming to the creating the surfaces, here in the surfaces toolbar you can see there are different options here in the like extrude, revolve, sphere, cylinder, offset, sweep, fill, and multi-selection surface, blend surface. So we are going to see one by one. Firstly, we are going to see the creating the extruded surfaces here. So for that, firstly I am selecting a plane here. Go to Sketcher and use creating some spline here, and exit the Sketcher. And now I am going to select this extrude option, selecting the sketch, and direction, and sketch normal to the sketch, and you can extrude here, or else can give mirror extent and give the value as 50 or 200 whatever the value you can give it. So this is a simple extrude option. Can give the instead of mirror, can give two dimensions. One is 200 and on other side can give as 500. So this is a simple surface created from the spline sketch here using the extrude option here. So this is about the extruding the surfaces. If you see here, uh, we extruded the from the 2D, we created this 3D surface by using extruding, as I already told you. So from this I'm going to create another extrusion. Select the extrude option and see I'm selecting this edge as the profile. In the direction I'm going to select is ZX plane. Let's change the direction again, selecting YZ plane. It is not possible in this direction, so let's see XY plane. So if you see, I haven't created any 2D profile here. I just selected the edge here. I've already created extruded feature and I just selected the edge, and for that edge I given the direction and the limits. Okay, select OK, and now I'm going to again select this edge here and let's see the direction I'm going to give is this is the direction. Now direction I'm going to give is XY plane. So here I got the shape like this from the edge itself of already created profile without creating any 2D sketch as a profile. I just selected the edge of already created extruded wireframe surface, so that edge has been used as a profile, and by giving the direction reference you can create the extrusion like this very clearly I have shown you. So this is about extrusion option. And one more thing, firstly let me delete this one. Now if you go for this extrude option and the profile I'm going to selected this as the profile. So let's see what will happen in the direction I'm selecting this. Okay, let's change the direction. Okay, the next direction. Okay, so direction is selected as XY plane as the direction. So profile I selected, the whole profile I selected. So you see the result of it. And now click OK and let me delete this side. So, all sides are linked together. So if you delete one side, the whole thing will be deleted. So there is a section view. Right click. Is there any section? It is not there. Selection sets. Okay. Go to insert, wireframe. So okay, there is no section in this wireframe and surface to see the inside. And so do this isolate option. So this surface has been isolated. So I'm deleting the surface. Same thing happened. So this is how it works when you use select the whole profile. When I select this one, the whole all the four sets got selected at a time and they were extruded using this extrude option. So again I'm using the extrude option and selecting the edges individually. See, I'm given the direction itself. I selected this edge and selected this edge and direction I'm giving as this edge. So this is what happens. And again I'm selecting this edge as a profile and this edge as the direction as this edge. So it is a spline shape, so there are no uh, continuity there. So if I select this plane, this is okay. This is about the abstract option, extrude option. So here even you can select even the point apart from the edges. You can select the profile as this point. The direction I want to give as this XY plane. So here I can, so second limit I'm taking as 0. So the first limit pretty okay. So this way you can even extrude point instead of a ed edges and the profile of the surface. We can even select a point or the vertex and extrude that one to the limit by giving the dimension, the direction difference. So in this way you can even extrude a point from the any specified profile and give the limits, and this is the result. So let's delete this one. And coming to the last thing here, if you select this profile, we can see that all the edges and all the vertices are getting selected by selecting the old profile and giving the direction reference. We are getting this one. So instead of that, we want only 3 edges. We want to select individually. Then let's see, select, go to this extrude option in the profile, right click. Here you can see create multiple extract option. Select that one. So here elements to extract, it is asking the elements to be extracted. So I am selecting the center edge and this one, this edge and this edge. So I selected three elements I selected, and propagation type I selected no propagation. The default one. See the preview. Click OK. Here you can see there are 3 different options. It is showing keep only one sub element using an year. So let's click OK. It's asking for reference element. So I am selecting this XY plane as a reference. See the preview. It's not showing preview. Okay. So there is nothing direction. It is asking this one. There is no use. This one. So this I got. Delete this one. This is possible even like this also. There's nothing much useful here. So right click again, create multiple elements, and here you can add this one, this one. So again I'm trying. So in this no propagation, click OK. So here I'm selecting second one. Keep only one sub element using an extract option. OK. Elements to extract. I'm selecting this one and this one. The preview. OK. Direction XY plane. Again cancel. Again go to extrude. From right click, create multiple extract. Select this one, again this one, and again this one, and again clicking OK. So here you go for the, here in this both options only one sub element is shown. So that's the reason why you got only one element selected and that has been extruded. So first thing is using a near, the sub element is selected using the near option, and one sub element is using an extract option. The third one, keep all the sub elements. Let's see what will happen. And direction XY plane. See, it is showing extrusion operator. Selected contour is self-intersecting. The contour cannot be used. An extrusion choose a wire is not self-intersecting. So go for this element 2 selected and remove. So let's see the preview. Okay, okay. So now they are not self-intersecting. And if you go on again, I'm going to add this one also and click Okay, so this is what happened here, and again going clicking on this right side, and in this propagation type and tangent continuity, see the preview, and again curvature continuity. So these are all different types of propagations, so which we have seen in while doing the filleting, while using the fillet option in the part design workbench. So we have came across this propagation type like tangency and continuity. So the point continuity is similar to that. So if you selected this point continuity, you can see that all the four edges have been selected because at the end point it is used for continuing for the second endpoint, and from second endpoint this goes on continuing. That is propagation. It's nothing but continuing. Whereas in tangency, if the edges are like fillet is there, or edges are round shaped, it will automatically select the uh, other unselected element by using this propagation type, using this tangency continuity option here. Keep that, then the continuity will goes on to the next element even if you are not added the element here. So as I kept the point continuity, so the vertex having the point, so the continuity created here even if you are not selected the element. So so we'll keep this no propagation. Then you can see the only three sides have been which you have selected have been created here. So this is about this multiple extract, and hope you understood. Now I am trying to go for this next option here, is the revolve option here. So this option is used to create the uh, revolved revolving a profile around about an axis. So to create a revolved axis, first you need to have a profile on the axis to which you want it should be constrained. So let's use the same sketch that we have created. So let's move a little bit far from here. Okay, let's exit the sketcher, and if you see here, let's fit this whichever way you want. So here if you see the revolve option selected, and profile I'm selecting this line, revolution axis I'm selecting as this h value here. You can see the result here, the angle 1 and angle 2. You can change the angle. If you give this as 360 degrees, the complete, you can see this is a simple option which are not there, it is not having uh, any criticality here. They are simple, there are only three features here: profile and revolution axis, three options: profile and revolution axis and angular limits. These are the only three options or parameters with which we can control this evolution or the revolve. feature here. So this is simple here. So you need to select the profile and you need to give the center axis, set the center axis and give the angles. That's it. So this is about the revolve axis surfaces. The next thing here is creating a spherical surfaces. So this tool is used to create spherical surfaces here. This sphere here is used. So let's delete this one and open this sphere here. So here it is asking the center point. So let's create, right click and create point, and you can use any of these options. The coordinates, or there is a curve pre-existing, so on that curve you can create. There is plane, on plane, there are planes here, so the on plane you can create. So there is existing surface, so on that surface you can create this, or circles or sphere, ellipse, center, so tangent on curve or between. So you can use any of these point types and create a point. And I'm using a coordinates here and giving this origin as a point. So C, okay, and giving the radius as 100. Let's give 500. So now here this start point it is asking for. So you can change any position in any direction, or here or here, or else you can give the whole sphere. Then we will be getting the whole sphere simply without any angles. The only variation or variable property here is the radius. So here you can just change the radius. So that is the only variable is the radius when you are selecting this complete sphere. Whereas in keeping the limitations here, you need to give the change the angles on parallel end angle, parallel start angle. So this is the parallel start and the parallel end, and then the middle you can see the meridian start and meridian end on the other side here. So this is, you can change them as you required it. So this is about the sphere. And the next option you are going to see is creating the cylindrical surfaces. So this is used to create cylindrical shapes here. So for that, let's go for this cylinder and select the point. So create point. Even now in this can create points in a different ways. Can create. So one is, if you have any lines here, existing lines, pre-existing lines, so you can select that and create midpoint. So the midpoint of that pre-existing line will be used as the uh, center point for creating the cylinder. The same way as and create intersection. So there are different point options. Let's create point. I'm selecting okay, let's keep it on plane. I'm selecting this as a plane. Kept here the point, and now the direction I need to give as this plane. I'm giving as a direction. So you can see cylinder has been created here, and the limits, two limits, you can drag and leave it, or you can change the values here. And the diameter radius is 20, I can give 50. So if you change the direction of the reference here, so instead of that I'm selecting this plane, and again instead of that I'm selecting this plane. So you can see the changes happening. So this is a simple example for the cylinder option here. So we'll see the next one is offset feature. So let's cancel this one. Or so for suppose if you take the cylinder itself, I'm selecting this point as a cylinder, or as I told you, create midpoint. Selecting this, so the midpoint has been created. Now the direction has to begin. I'm giving this as the direction. Or let's see if it is possible to select the direction as this profile. It's not possible. It's a varying direction. So giving radius as 100 and click OK. So let's use this offset option here. Select the offset option and selecting this cylinder surface as a surface to be offsetted, giving the value as 50 here, and smoothing none, and see the preview. So you can see the it has been offsetted at an offset distance of 50 mm here. Smoothing none, automatic or manual, you can so maximum deviation, you can maximum deviation is a 0.1. So if you keep 0.2, I think it won't take 0.2. The limit will be uh, out of range. The value is 0.1 is restored. Should be 0.5 to 50 microns to 100 microns is the maximum deviation. So you can keep it automatic or keep none. So if you select the both sides and see the preview for the offset on the both sides. So in the sub-elements to remove, there are more than one element so that you can remove the remaining unnecessary elements. So if so here there is only one main element here. So if I remove this, it's showing the error message because the offsetted surface is dependent on this main sub element, so it's not possible to remove. So just cancel this one. So this is about the cylinder option here. The next options here is sweep, the fill option, and multi section surface, and blend option here. So firstly we'll go for fill option, and you will see the blend option. We'll see the both these options, and then we will go for this multi selections section surface, and later we'll go for the sweep option. So coming to this fill option, so let's see the same example. Select the fill option, selecting this face, this side of the face should be closed, and selecting this edge. This is a closed contour, so we can just see the preview. So you can see it is closed up. So you can see opening got filled in the by selecting the curve here. So you can add this edge also. Sorry, this edge. Add after select, um, and then see the preview. Okay, so it's not possible to create multiple fields at a time. You need to do one by one. Right the fill here, select this circular shape and see the preview. So this is closed one now. So in the same way, so let me create another profile. So for that I'm using the spline option here, spline option here, and create point. Okay, and another point is 200, 200, 200. Okay, and create another point here at 500, 500, 500. Okay, so for x, coming to the x side, I kept 500. For y, I kept 50, and coming to the z, I am giving 200. So let's click OK. Okay, let's make it closed line. So we got this closed. Okay, see the shape here. So let's use the fill option now. Selecting this closed contour and see the preview. Not possible. As you can see, it is well twisted. So let's do one thing. Just extrude this one. The direction of, you can see clearly they are twisted. So think we need to change the point location here. Remove the close plane and select edit point. I need to give this value as 10 and y 300 and z 50 preview. Select close plane and then it is intersecting. Move this close plane and change point option. The y I am giving as minus 300. Let's see. Let's use a close plane. That is quite okay. They are not overlapping in or intersecting each other. It's okay now. Now let's use this fill option now. Selecting this one. See the preview. So you can see this is not overlapping, or if you want to have an idea, just confirming with using extrude option, giving the direction as this xy plane here. It's a plane here. So plane. You can see clearly there is no overlaps here. They are clearly open profile. So you can select OK, and even for this, select this edge and use the preview OK. So we got this and edges, and one side is closed using this fill option. So this is how we can use the fill option here. And coming to the next one is the blend surfaces. So for that, so for using this blend surfaces here, so before going further, so I think that we need to end this section right now, because I got to go now and in a hurry. So anyway, we completed the extrude option, revolve option, sphere option, cylindrical, cylinder, and the offset option, and even the fill option. So the only three options that are left in this surfaces toolbar is the sweep option and multi-section surface, the blend option. We'll see the three things, these three different operations: blend, multi-section surface, and sweep in the next class. So I hope practice until what I told right up to now. The different options of what we discussed in this class, you can practice them. If you have any doubts, you can comment in the comment section. So I hope you enjoy the video, and I think I can improve a lot more, can give you a better explanation if you have any doubts. So I hope you understand, guys. Bye bye.